हेलो एवरीवन। आज हम लोग डायनेमिक्स में जो क्वेश्चन बैंक के सॉल्यूशंस को लास्ट क्लास में कर रहे थे उसको आगे बढ़ते हुए नेक्स्ट क्वेश्चन की तरफ बढ़ते हैं। तो हम लोगों ने लास्ट क्लास में जो क्वेश्चन देखा था वो कुछ इस तरह से आई थिंक दैट वाज फॉर द 5A एंड द 5B। नाउ टुडे वी आर गोइंग टू डू द क्वेश्चन नंबर this one is the question number 7A. We have completed 6A and B. Now today we will do the questions of dynamics 2020. Okay. सबसे पहले इस क्वेश्चंस को जो हम लोग करेंगे 6-7 की ए नंबर पे, तो ये करने से पहले हम लोग थोड़ा डेफिनेशन देख लेते हैं इनवर्स स्क्वायर लॉ का कि व्हाट वी मीन बाय द इनवर्स स्क्वायर लॉ ऑफ ग्रेविटी, बिकॉज वी आर गोइंग टू यूज दिस कॉन्सेप्ट हियर इन दिस क्वेश्चन। सो इनवर्स स्क्वायर लॉ जब भी हम बात करते हैं तो इसका हमने प्रूव करते हैं कि एफ इज इनवर्सली प्रोपोर्शनल टू आर स्क्वायर। ओके, सो हियर we find where this concept comes from. So let's see the concept. If we will take a body in a circular path, okay, and this body moving in a circle with constant speed from here in this way. So to complete a one complete circle, जो इसे टाइम लगेगा ये हम लोग मान लेते हैं वो है कैपिटल टी के बराबर। फाइन। तो इस बॉडी में क्योंकि सर्कुलर मोशन में मूव कर रहा है तो इस बॉडी के ऊपर एक सेंट्रीपिटल फोर्स काम करेगा जो कि सेंटर के टुवर्ड होगा। ओके, एक सेंट्रीपिटल फोर्स कैपिटल एफ काम करेगा जो कि कहाँ होगा, तो डायरेक्शन इसका होगा आपके सेंटर की तरफ। फाइन, एंड लेट दिस radius of the circle is r. So to prove this concept, the f is inversely proportional to r square. We'll write, first of all, we consider an object. Okay. Moving in a circle. Fine. Moving in a circle with constant speed. This one is the constant speed. Then since there's a centripetal force is always directed towards the center. So here this capital F is what? This one is the centripetal force. Always directed towards the center of the circle. Always directed towards the center of the circle. Fine. So the formula for the centripetal force is mv square divided by r. Okay. Here m is the mass of the body and v here is taken as a distance, velocity, but actually it is a speed. तो यहाँ पे जो v है वो actually है तो velocity, but in this figure we will consider it like a speed. So the v is equals to what? Distance by time. Fine. Okay. And here what we mean by the distance. So to एक पूरे रोटेशन को कंप्लीट करने में यहाँ से इस पॉइंट से अगर इसने स्टार्ट करा है पॉइंट ए से और फिर वापस से पॉइंट ए पे ही आने पे जितना इसने डिस्टेंस कवर करा है, दिस डिस्टेंस is what is the circumference of the circle, and this is equals to 2 pi r because r is the radius of the circle, and the total time for the one complete rotation I have taken is a capital T. So now I'm going to write here the capital T. Okay, so now we'll put this value of v 2 pi r divided by T in this centripetal force. So the F is will become m into 2 pi r divided by T whole square and divided by r. So while solving this value, we have here m 4 pi square Okay, here it is r square and r we're going to cancel out. So I am leaving with only r by t. Fine. Now this one is the condition. हमें इतना यहाँ पे एक वैल्यू मिल गया. अब यहाँ पे देखो m4 and pi square, all these are the constant, and this r by t is your variable. So जब ये बॉडी हमारी मूव कर रही है इस सर्कल पे, तो हम यहाँ पे एक k प्लस थर्ड लॉ को अप्लाई करेंगे. तो k प्लस थर्ड लॉ से हमें पता है कि टी स्क्वेयर जो है वो डायरेक्टली प्रोपोर्शनल होती है आर क्यू के बराबर. ओके, एंड so from where this comes from, so ये जो r by t square यहाँ पे है, ये जो r by, sorry here it is t, so t square, ये जो r by t square है, this will give you the k plus third law. यहाँ पे हम अप्लाई कर रहे हैं. so t square is proportional to r cube. ओके, तो इसे हम ऐसे लिख सकते हैं, this imply t square equal to k into r cube, and therefore we have the value r cube divided by t square is equals to 1 by k. So now I'm going to put this value from here in this equation. Let's put this equation number 1. Let it be the equation number 2. Okay. So from equation number 1 and 2, हम यहाँ से क्या देख सकते हैं कि इस इक्वेशन नंबर 1 में अगर हमें 2 को अप्लाई करना है तो थोड़े से चेंजेस हमें यहाँ पे करने होंगे. So now first of all I am going to write the equation number 1 as f equal to m 4m pi square r cube divided by t square, and I am going to divide here by r square. So r square cancel, then we have r by t square. So nothing is going to change in this equation. Now I'm going to put this value r cube divided by t square equal to 1 by k. So what we are left with? We left with 4m pi square divided by r square into k. Now you see here the 4 pi m pi square divided by k, this quantity is a constant value. Okay, so can we write this value as a 1 by r square into constant? Okay, and since this is a multiple of constant, so here f is equal to 1 by r square, and here it is some constant. So can we write this value as f is proportional to 1 by r square? Okay, so here this concept we say this is the inverse square law. Why? Because f is inversely proportional to r square. And r is what? R is the distance of the particle from the center. So the question which will ask in your exam is like this. So I'm going to write the question first. Okay. So here is this question which was asked in your exam is 7a. This one is your 7a. Okay. The question is a particle moves in a plane under an acceleration whose magnitude is mu divided by distance whole square, where mu is a constant, here it is mu is written, and which is always directed towards a fixed point in the plane, so that the path is a conic, and distinguish the three cases that may be arise. Okay. So by saying this question, first of all thing which will comes in our mind is the particle moves in a plane, okay, under an acceleration, and whose magnitude is mu by distance whole square. And just we have seen that while we are talking about the inverse square law, f is proportional to what? 1 by r square. Here this value f is given as mu by r square. Fine. So it means this is the questions in inverse square law. Next thing which we see in this question is this magnitude mu by distance whole square and the acceleration is always directed toward a fixed point. मतलब यहाँ पे कोई एक पॉइंट अगर फिक्स्ड है और ये इसके इसी की तरफ इस प्लेन में क्या कर रहा है, इसी से डायरेक्ट हो रहा है, यहाँ पे इसके डायरेक्शन में यहाँ पे एक फोर्स काम कर रहा है एंड दिस इज व्हाट, दिस इज योर fixed point and is always directed toward a fixed point. So from here we will see this fixed point is known as what? This is the central की तरफ में हमें force लगा रहे हैं. Since the force is always directed to a fixed point, let it be O. Okay. If we put this as O and the force is always directed toward a fixed point, so this is the case of what? Central orbit. Why? Because while defining the central orbit, we have seen the definition of the central orbit as that the center of when a particle, okay, when a particle moves in a plane under the influence of central forces, मतलब कोई particle अगर किसी plane में move करता है, मान लो यहाँ पे ये particle move कर रहा है इस plane में under the influence of a central force, तो central force अगर यहाँ पे है तो ये फोर्स जो है इसे डायरेक्टेड कहाँ पे, सेंटर की तरफ ये ऑलवेज डायरेक्टेड होगा लाइक दिस. ओके, दैट इज अ फोर्स एक्टिंग ऑन द पार्टिकल एंड इज ऑलवेज डायरेक्टेड टुवर्ड्स अ फिक्स्ड पॉइंट ऑन दिस प्लेन. देन the path traversed by the particle is known as the central orbit. Okay, so we can write like this, here the force is always always directed to a fixed point, directed to a fixed point. Okay, so it is a case of central orbit. Okay, so this is a case of central orbit, and you can just make this figure beside this statement, and we know that the pedal form of the differential equation of central orbit, which we have done in the previous classes, is like h square divided by pq dp divided by dr is equals to p, and this is here mu by r square. You can write p in place of f. Okay, we have written here p. You can use f. So here we get this from the definition of the differential equation of central orbit. Fine. Now put this as equation number 1. Now, so here it is. Now integrating 1, we get. So while integrating this value, what we have here, we have h square dp divided by pq, and this is equals to mu 1 by r square then dr. So from this equation, what we have in our hand is minus 1 by 2 h square by p square, and this value is equal to what? Minus mu. Here it is minus mu क्योंकि यहाँ पर एक minus मिलेगा, divided by r and some constant, say let it be capital A. While solving this equation, we have here this h square divided by p square is equal to 2 mu divided by r plus a by 2, and we can write this equation as h square by p square equal to 2 mu divided by r plus say b. But we know that the velocity of okay, now we know that from the previous lectures that in every central orbit, the sectoral area pressed out the radius vector to the center of forces increases uniformly per unit of the time, and the linear velocity varies inversely as the perpendicular from the center upon the tangent to the path. तो ये हम लोगों ने पहले भी कर चुका है. तो now we have to remember only one thing, that कि the linear velocity, okay, right, we know that the linear velocity of the particle varies inversely from the center upon the tangent to the path. Okay, so we have no need to prove this here. Only we are going to use this equation here. That is what V equal to. That is V equal to 1 by P, and this apply V equals to H by P. Now, since V equal to H by P, so we can write this one as this imply V square equal to H square by P square. Fine. And let be the equation number 2, and this is equation number 3. So from 2 and 3 we have, from equation 2 and 3 we have, so what we have here, we have V square equal to H square by P square, and this is 2 mu divided by R plus B. Okay, let's put this as equation number 4. But here we are going to find the equations of the conic section, and we are going to distinguish that situation sections with the equation number 4. So now we know that, okay, we know that refer to the focus as 4, refer to the focus as pole, the pedal equation of the parabola, the pedal equation of the parabola is given by what this value is, P square equal to A into R. Fine. So here if P square equal to A by R, where A is what? Where 4A is the length of the lattice rectum. Okay. Fine. So we have just written that पैराबोला की कंसिडर हम लोगों ने किया था, और हम लोगों ने लिखा कि पी स्क्वायर जो है ये इक्वल टू है आपके now p square equal to air is equation number 4, where 4a is the length of the lattice rectum, okay, fine. So we have the equation number 3 as v square equal to h square by p square equals to 2 mu divided by r plus b. This is the equation number 3. Now I'm going to compare this equation number 3 and the 4 and find the conditions. So now comparing equation 3 and 4 we have. So what we have here goes, see here is p square and we have p square in the denominator. Okay. And in the numerator we have h square, so I'm going to write like this. Here it is h square. Okay, here nothing is here, so we can write like this 1 divided by, so I'm writing here divided by 1. Okay, now this is what 2 mu, here it is r, so I can write like this 1 by p square equal to r, here it is r, so a 1 by r divided by 1 by a, like this you can write like this, और उसको हम लोग repeat भी कर सकते हैं. So 2 mu divided by 1 by a, and this is equals to what, b divided by 0, क्योंकि इसके आगे कुछ है नहीं तो हम लोग यहाँ पे लिख सकते हैं प्लस 0. So we have b divided by 0. Fine. So now while writing this values, you can also write like this 1 divided by a into r. Okay, so here it is 1 by r, so better you can compare 1 by r, and here it is also 1 by r. Now while comparing this value, we have here v square. Okay, you just write the v square here, or you can write these three terms. So now from first and second terms क्या मिलेगी, इन दोनों को हम कंपेयर करते हैं तो हमें क्या मिलेगा, एच स्क्वायर की वैल्यू हो जाएगी 2 म्यू ए के बराबर. एंड फ्रॉम सेकेंड एंड थर्ड what we have b equals to 0. So therefore equation 3 implies, तो इक्वेशन 3 से हमें क्या मिल जाएगा, क्योंकि एच स्क्वायर की वैल्यू हमें 2 म्यू ए मिला है तो इस वैल्यू को यहाँ यूज करेंगे. सो वी आर हैविंग v स्क्वायर इक्वल टू एच स्क्वायर की जगह पे लिखेंगे 2 म्यू ए डिवाइडेड बाय p स्क्वायर. फाइन. And this value is also equal to what, 2 mu divided by r plus 0. Ultimately we can write like this कि v square is equals to 2 mu divided by r, क्योंकि हम लोग जनरली यहाँ पे जो वेलोसिटी दिखा रहे हैं, स्पीड को दिखा रहे हैं, वो इन टर्म्स ऑफ r दिखा रहे हैं, क्योंकि हम लोग इनवर्स स्क्वायर लॉ अप्लाई कर रहे हैं. तो हमारी ये कोशिश होगी जितने भी कांस्टेंट टर्म को हम यहाँ पे ना दिखाते हुए ओनली द टर्म्स वी हैव टेकन इन द फिगर r v, उन्हीं को हम लोग यूज करें. So we have here is a v square equal to 2 mu divided by r, and here v square is equals to 2 mu divided by r. So this is the condition in case of the parabola. Okay, this will ask in your exam for the objective questions, so for the 1 marks also. So you just remember this condition. Now let's come to the case 2. When the path is elliptic. When the path is elliptic. Or you can also draw the figure here of the ellipse. अगर elliptic path है तो इसके major axis and the minor axis भी होंगे. So let the major axis be 2a. Okay, and here it is 2p. So let it be the point a dash. This is b and b dash 0 is the center, like this. So while writing the conditions, the thing which you remain in your mind is what we are going to use the pedal form. Okay, so first you write the pedal equation of ellipse. क्या है ये? This one is your b square divided by a square is equals to 2a divided by r minus 1. Put this as equation number 4, and then I think this one is the 5. Fine. 4, okay, you can write this one as 5, then this will be your 6. Fine. Now I'm going to compare here the equation number 3 and the equation number 6. So now you write this comparing 3 and 6. We get. So while comparing 3 and 6, what you have here, so we can write like this. देखो यहाँ पे ये क्या है, ये b square divided by p square. So b square divided by here it is p square. Okay. Sorry, I have just mistakenly written here the p a square in terms of p square. So you just write the h square b square divided by p square equal to 2a divided by r minus 1. ऐसा हम लोग इसलिए ले रहे हैं क्योंकि जब पेडल फॉर्म की हम बात करते हैं तो पेडल फॉर्म जब हम लोगों ने बनाया है तो ये अगर हम लोगों का पोल है तो पेडल फॉर्म में ये हमारा कब होता है दिस रिलेटेड द पॉइंट पी, तो इस तरह से हम लोग यहाँ पे ले लेते हैं इस तरह से पॉइंट पी को। तो ये जो डिस्टेंस हम लोग कवर करते हैं दिस वन इज द कैपिटल P and this P is worked here, so P square. Okay. Now while comparing the equation number 3 and the 6, what we have V square equal to, so here it is a P square. So while comparing these two values, what we are going to write here is H square divided by B square. Okay. Here it is P square, so I'm going to write H square divided by B square equal to mu divided by A. See here, this was a 2 by r. Here it is 2 by r. So here it is your mu, here it is your a. So mu by a. And this is equal to b. And here it is plus b, but here it is a minus 1. Or while writing this one plus, we get the minus 1 here. So I'm writing here the minus 1. Okay. So we get this value here by comparing equation number 6 and 3. Now taking the first two terms from first two terms. तो फर्स्ट टू टर्म से हमें क्या मिल जाएंगे, फर्स्ट टू टर्म से हमें ये मिल रहा है कि एच स्क्वायर की जो वैल्यू है वो म्यू पी स्क्वायर डिवाइडेड बाई ए के बराबर है. ओके, एंड फ्रॉम द लास्ट टू टर्म्स से हमें क्या मिल जाता है, बी की वैल्यू. So I'm getting b as minus mu divided by a. Now I'm going to put this value here in the equation number 3. So from 3, so putting this value in equation number 3, we get putting these values in equation number 3 we get. तो इक्वेशन नंबर 3 में अब हमें क्या मिल जाएगा, हमें मिल जाएगा v स्क्वायर इक्वल टू h स्क्वायर बाय v स्क्वायर. तो यहाँ पे है h स्क्वायर बाय p स्क्वायर. So I'm going to write the value here. So h square divided by p square. So this is what mu b square divided by a, and here it is p square. Fine. Then we have 2 mu divided by r and plus b. So plus b की जगह पे हो जाएगा minus mu by a. Okay. So we can write this value as this is equal to what? Mu is taken the common. So I have here 2 divided by r minus 1 by a. Fine. So you see, while this equation, put this as equation number 7. So from 7 we have here v square की जो वैल्यू है यहाँ पे, because this is the multiple of 2 mu by r, लेकिन यहाँ से हम minus 1 by a कर रहे हैं. दैट मीन्स आप कितना भी यहाँ पे वैल्यू कर लो, क्योंकि यहाँ पे हम वैल्यूज को माइनस करते जा रहे हैं और ये डिपेंड कर रहा है ए की वैल्यू पे. सो दिस विल राइट माई लेस देन 2 म्यू डिवाइडेड बाय आर. और ये ए क्या है, तो ए इज द लेंथ ऑफ द मेजर एक्सिस. सो आई हैव नॉट रिटन हियर, बट यू जस्ट राइट हियर वेयर 2a and 2b are the length of major axis and the minor axis respectively. Major axis and minor axis respectively. Okay, so you get the better marks in your exams. So I'm just writing here within the bracket this one. Fine. तो यहाँ पे हमने देखला कि v स्क्वायर की जो वैल्यू है वो 2 म्यू डिवाइडेड बाय r से कैसे होगी, आपकी छोटी होगी. तो कंडीशन क्या होगा, ये कंडीशन हो जाएगा आपके इलिप्स की. अब आते हैं नेक्स्ट वन पे. नेक्स्ट है हमारा हाइपरबोलिक केस. ओके, नाउ केस 3, when the path is hyperbolic. When the path is hyperbolic. So while the case of the hyperbolic, first we'll write the pedal form of the hyperbola. So we know that the pedal equation of hyperbola is, okay, ये इक्वेशन कितना है, b स्क्वेयर डिवाइडेड बाय p स्क्वेयर इक्वल टू 2a divided by r plus 1, while in the ellipse we have a minus 1. Okay, so let's put this as equation number 8. And we have it from equation number 3 as what? H square v square equal to h square by p square equal to 2 mu divided by r plus b. This is the equation number 3. Okay, I'm writing side by side here. Now, so in the case of hyperbola, what we have this 2a and this b. Okay, so now I'm going to mention this value here. So where 2a and 2b are the length of transverse and conjugate axis respectively. Fine. Now comparing equation 3 and 8 we have, तो हम लोगों को यहाँ पे कंपेयर करेंगे तो क्या मिल जाएगा? यहाँ से हमें मिल जाएगा कि h square divided by, see this b square by p square, here it is h square by p square, so h square divided by b square, this is equals to what? 2 mu divided by 2a divided by, so here it is mu divided by a. Fine. And this is equal to what? b divided by 1. So this is almost the same, but we have a sign. वहाँ पे minus के sign होते थे, यहाँ पे plus का sign है. So now we have here the h square equal to what? Mu b square divided by a, and b is equals to what? Mu by a. Now I'm going to put this value from here to equation number 3. Now putting this value in equation number 3, what we have? Putting these values in equation number 3. So we have from equation number 3 as v square equal to mu, okay, b square divided by a, we have p here, and this is equals to 2 mu divided by r plus mu by a. Fine. While solving this value here, v square is equal to what? Mu 2 divided by v r, sorry, this is r, plus mu divided by a. Equation number 9. This is the condition for the hyperbolic case. Now here, v square is always greater than 2 mu divided by r. Fine. Now from all these three conditions, what we see is thus, from the above three cases, we conclude that equation 1 always represents a conic section. Fine. Always represents a conic section. And whose focus is as the force. And whose focus is as the center of force. Fine. So from here we note that while in the case of the parabolic path, h square की जो value है, this is equal to what? 2 mu a. Okay. h square की value जो है वो 2 mu divided a के बराबर, and this is what? This is equals to mu l. Mu p square divided by. So here in the case of the, सबसे पहले पैराबोला का देखते हैं. देखो, in the parabola what we see, in the parabolic case we see that h square की जो value है वो 2 mu a के बराबर थी, and this is equal to what? Mu, and here it is 2a, so 2 is the length of the latest rectum, so I am writing here l, the semi-latest rectum. So this is your mu l. Now in the case of the ellipse, we have h square की value थी mu b square divided by a के बराबर, and here b square divided by a is your l. So this we can write this as mu by L. And in the case of the hyperbola, we have h square again equals to mu v square by a, and this is equals to what? Again this is equals to mu L. Okay. So here we see that in all the three cases, h is what? Here, in all the three cases, h is equals to root over mu L. Here it is h square equals to mu L. Again, we have h square equal to mu L, and the hyperbolic case, we also have h square equal to mu L. So, all in the three cases, either it is a parabola, it is a hyperbola, or it is a ellipse, h is equals to root over mu L. And what this value of L is? So, here L is the length of semi-latus rectum. Here L is the length of semi-latus rectum. तो अगर ये क्वेश्चन एग्जाम में पूछा जाता है तो हम लोग को इतना सारा डिस्कस करना होगा, तभी आपको पूरे फुल पॉइंट्स दिए जाएंगे। ओके, तो आज के लिए इतना ही ध्यान देते हैं, फिर नेक्स्ट क्लास में हम लोग इसके नेक्स्ट क्वेश्चन को देखेंगे। थैंक यू ऑल।